Hey everybody, and good morning. It is Mrs. C, and I am coming to you with yet again another video on translating geometric problems algebraically and then solving for whatever thing they want to side. Is it a perimeter? In future, it'll be area. For now, it's gonna stay linear for us so that we don't have anything too saucy. We don't want to saucify too much. So let me just clean my board here. Oops. You know, it's important to have a nice clean board, but sometimes I don't do the prep work. I want to get you ready. Are you ready? Are you ready to do this? Stop saying no. Yes, you are. That's why you're here. So if you look at number 1, let's see, 2, 3, 4. 1 through 4 are rectangle problems. And if you proceed down, you will see 5 and 6 say triangle, 7 goes back to rectangle, and 8 is an isosceles triangle. Ooh, getting saucy with the terminology. Vocab, people. Isosceles, that's all I have to say. So I thought maybe we would try maybe a triangle, try a rectangle, and then go to the next page. I have a little more practice. Leave this for you. Let you see the answers before I go. And so let's just jump into it. Let's go. Eeny, meeny, miny, mo. Let's start with something that we know. Let's do a rectangle. And I'm going to go to number 4. I'm going to try the hardest rectangle there is on the page. So I already said it's a rectangle, so there we go. The length of a rectangle, again, I am on number 4. The length of a rectangle is 2 centimeters less than 7 times the width. 2 centimeters. Can I make that bigger? Well, I can make that bigger, but it makes everything else bigger. So let's go there for a minute. The length of a rectangle is 2 less than 7 times the width. 2 less than 7 times the width. The width is the width. The perimeter is 60. So let's bring her on down here back to a normal size, and let's just put that in. It said the length was 7w minus 2, so let's put that there, 7w minus 2, and the width is just the width, and the perimeter is 60. Just a straightforward problem. Now it is 60 centimeters. I'll put that there just to remind me. Don't know why my stylus isn't working. Just to remind me what my answer is going to be labeled in. So, one little mistake I just want to throw out to you guys is the individuals that don't label around the sides will have a tendency to forget that when you add up all the sides, there are 4 and not 2. So a common translation I see at this point is to write your process 8w minus 2, to add the 7 and the 1 and then be done. That's not correct, guys. You got a w over here. You've got 7w minus 2 down here. So when you go around and you add up your like terms, please do remember you have 4 sides and you don't have 4 w's. Why don't you have 4 w's? Because 2 of your w terms are worth 7 each. So please, 7 and 7 is 14, 15, 16. You have a 16w term. And don't forget your constants. A negative 2, 0, negative 2, 0. We have a negative 4. Same sign, sum. Keep the sign. And then we bring it right to a basic problem. Two-stepper or two-steppin'. And we just solve this. We add 4 to both sides. This is when you really want to pay attention and don't screw up. You made it this far. You better bring it home. And then we do 16 into 64. Oops, squeaky, squeaky. Okay, so last step would just be able to cancel out my 16. 16 divided by 4. Let's see. How many times does 16 go into 4? Well, 16 times, 16 times, 4. 16 times 4, would that work? I don't have a calculator, so I want to double check. Yeah, 24. There it is. Okay. So let's go with what we know so far. I have a w equal to, I said 4. Now, I always look back up and see what the heck did they ask me to solve for, because I could be doing all this for nothing. It said find the width and the length. So my final answer needs to be both the width and the length. So let me choose a different color so you can see the evaluating. If this is 4 and this is 4, you have a width of 4, which we already knew. So I have the W is equal to 4. And I have 7 times 4 minus 2 gives me my length. So 7 times 4 is 28. 27, 26. I have a length of 26. Now don't forget your labels. Centimeters here as well. Centimeters. All right. Now the fun part will be to see if we got that right. And now you're going to see the answer choices coming to you. 4 and 26. That's what I'm looking for. You see it? There it is. 4 and 26 are the dimensions. All right, now you can see the answers. I'm not trying to hide them from you. I'm just trying to give myself space to work. So, fear not, my younglings. Let's go and kind of went through all that just to cover it back up again. Oh, it's no problem. It's kind of fun, actually. It's a little therapeutic. I recommend you all get a little whiteboard on your iPads or your smart devices and do a little coloring. Let's try a triangle. Now, I want to do a triangle, but I don't want to do one too saucy. So I'm going to maybe start with the first one and hope that that's not a saucy one. So it tells me that I have, that's the first one, guys, would be right here, number 5. The perimeter of a triangle. Okay, so I know I'm drawing a triangle. And for those of you that have seen my other videos, I always draw the same triangle unless they tell me it's a special triangle like a right triangle. Then I would draw a right triangle. But in this case, it just says a triangle, and it has a perimeter of 76. So I'm going to put the 76 there. I'm not even going to put my labels because I'm doing something a little different, and I don't want to overwhelm myself with information I don't need. Side A. Okay. I don't have any sides labeled, so here's where I have the choice of how do I want to label my sides. And in this case, if you look, they're calling them A, B, and C. And that is exactly what I'm going to do. I'm going to call my sides A, B, and C. You're going to now ask, does it matter which one's A? No, it's your triangle. Label it how you want. I seem to always put my A on the left side and then go clockwise. Well, let's continue. It says that side A of the triangle is twice as long as B. Okay, this is my side A, and they're telling me it's twice as long as B. So you out there, you, pay attention. How do you write twice the sides of B? Yes, to be. To be or not to be? That is the question. Name that quote from the literature. Literature, what is it? To be or not to be? To be or not to be? Hamlet. Very good. Shakespeare's Hamlet. So we have A is the same as to be. Let's see if we can get any more information. It says twice as long as B. We did that. Side C is 1 centimeter, 1 longer than side A. C is 1 longer than side A. Remember I said when you have more than, longer than, shorter than, that number goes in the back and then the thing goes in the front. Now with addition, it's not that important. It is important, but it's not that important mathematically, but it's a good habit to always be in. All right, now I've got that, and I think I'm good to go. Oh, this one is not as easy as it appears, and I'm going to explain why. I want you to look at the left side. I want you to look at this side here. We have 2 ways to call that side. We could call it 2A. We could call it 2B, or we could call it A. Those are its 2 names. Think of them as nicknames. Over here, this side, we can only refer to it as B. There's no other way to call it. It's B. I don't have an alternate way to call that, and that's going to be a good key for me. Now, if I look at this side, there's 2 ways to call it. I can call it C, or option, I can call it A plus 1. Now here's what you want to do. You want to find a commonality between the sides so that I can refer to them in the terms of the same letter. So if I call you A, I want to be able to refer to all of your sides in terms of A, meaning using the variable A instead of any other variable. That way, I could add up all the sides, I could combine like terms because they'd all be A's, and then I can solve for A. Easy breezy. However, are all my sides in terms of A? No. Oh, no, they are not, because if you look, I only have an A here. I don't have an A here. I have no way of calling B an A. Okay, so that's kind of a problem, right? But let's take a look at this a little bit. Let me get rid of those lines. I have this side in terms of B, and I have this side in terms of B. Is there any way I could tweak this and use something I know about one of the sides and swap in a B value? That's the question. Well, let's start with this one. Look around the other sides. Is there any reference to C over here? No. Is there any reference to C over here? No. So I can't refer to this side as C because there's no way to refer to the other sides as C. Let's look at this one. Well, let's start on this side. Is there any reference to to A? To A. Is there any reference to A over here on the B side? No. Is there any reference to A on this side? Oh, yes, there is. Look. You can call this side A, but you can also call this side, you got it, 2B. So if A is the same as 2B, then it would follow that I don't have to use A, I could use 2B because they're the same. They're interchangeable. It's like 4 quarters and $1. Which does it matter? If you go to the dollar store and you want to buy something, does it matter if you give them $1? And yes, I am not talking about tax. Just forget that for a minute. Thank you. Does it matter if you give them $1 or 4 quarters or 10 dimes? No, it doesn't matter. It's equivalence. And that's why we can swap in a 2B for an A. Now, it looks overwhelming. I totally get that. But it's important to try to grasp it. And then with practice in class, you're going to get much better at this. It's going to start to feel so much easier. So now, because I have everybody in terms of the same letter, I can now get a different color so you can really see it. Call everybody in terms of the thing that they have in common. Now, I know you may be asking, why is there still the +1 there, Mrs. C? Well, because the side C was referred to as 1 more than A. So if A is 2B, I still have to add 1 more to it. Otherwise, I'd have the same side as the other one. And there's a difference. At least that's what it told me. So now, algebraically, how do I pull this off? Well, the first thing is, I'm going to get rid of all this extra work because I need space to write. Bye-bye problem. So here's what I want to do. I want to remember that I have to add up all the sides, but only focus on the red boxes, right? I've got a 2B plus a B plus a 2B plus 1. Now you can throw those all down there and set them equal to 76, or you can add them in your head as you go around the triangle. It's up to you, whatever works best for you when it's this messy. So I have a 2B, and a 2B is 4B, 5B, any other B's? No, it's a triangle. There's not 4 of them. There's only 3. So I have 4 B's, and when I said there's only 3 of them, not 4. I think I said that the reverse. It's a triangle, so there's only 3 sides. So I'm only going to have 3 B terms. And in this case, a 2B and a 1B and a 2B. Why am I writing a 4? Is anybody going to try and stop me on that one? Because I'm playing with my colors. 2B and 2B is 4 plus 1 is 5. I don't know what the heck I said, but it should be 5 B's plus 1 is equal to 76. Then we simple, minus the 1 That gives me 75 over here where I don't have room to write it. Oh dear, 70. I'm out of room. I'm going to come over here. 75, and then it's 5b, and thankfully that's a pretty easy division step, right? 75 divided by 5, and so we get the answer b equals 15. Now, you can use a calculator. B equals 15. I'm so out of space, it's not even funny. B is equal to 15. 15. Now, if they ask me for side B, I'm done. If they didn't ask me for side B, I need to keep going. It says find the length of each side, excuse me. Okay. Now, I think I can just clean this up a bit and try to figure this out. I'm going to just, hopefully, I do not forget what all my sides were equal to. It's totally possible. I hope I don't. Okay. This side was 2b, right? And this side was b. And this side was 2b. It was one more or one less? I believe it was one more than side A. Okay, so then we found that b was equal to 15, right? We're going to find out if we're right or wrong. So this one's 15, because b is equal to 15. Okay, this one is equal to 30, because this one's equal to twice b. And this is like the three little piggies, right? The first little piggy is equal to 15. The second little piggy is equal to 30. And what's my third little piggy? Well, it's side, remember, it's this side plus 1. So 2b plus 1 is 30, plus 1 is 31. So this one should be 31. If you don't have an answer key, how do you know if you are correct? Well, the first thing, you can hear me pausing, I'm looking up to see. I'm so curious if I'm right because I forgot what the perimeter was. So I'm trying to look back at the problem. Excuse me, adjusting the iPad. The perimeter of the triangle, it says, is 76 centimeters. So if these numbers are right, they should add up to 76. And I do believe they do. 30 plus 31 is 30 plus 30 plus 10. 30 and 30 is 60, 70. And then 5 and 1 is 76. So add them however you want. I like to do a little mental math there. 76 is the perimeter, so I am good on this. I'm going to write my answers in ascending order. I'm going to write 15 centimeters, 30 centimeters, and 31 centimeters, meaning ascending order, the values are going up. Let's take a look for a moment and see if those answers are there. I don't know if they wrote it in ascending order. I like to. There it is. I don't have to go any further. 30, 15, and 31. Nope, looks like they did it in order of A, B, and C order. Okay. Now, guys, I try to keep this video short, and it's getting close to 20. I don't want to go over 20. So I'm going to give you a nice shot of the screen. Don't want to go over 20, but I might. Now, if you notice, hopefully you can read. Geez, I don't know if you can read that one. Let me do something. All right, do me a favor. Close your eyes for a minute. It won't matter. Close your eyes, it won't matter because I can't move it, I think. There. Close your eyes, close your eyes, close your eyes. Don't look. All right, now. Don't look, don't look, don't look, don't look. Are you peeking? I swear if you're peeking. Okay, you can look, open. Number 8 says the triangle shown at the right, and they gave you the right, but they gave you the triangle, but why can't you draw that? I know you can draw that. Follow the directions. It's a right isosceles. Do you know what a right isosceles is? Do you? Oh, for heaven's sakes. What do they teach you in school? Okay, a right isosceles triangle. That's not a right isosceles triangle. Oh my gosh, it doesn't even look like a right isosceles triangle. Okay, I had you close your eyes and now I'm showing it to you because I feel like you should know that and I don't think you do. I was joking. A right isosceles means it's got a right angle and it's an isosceles. So you can see how it has two sides that are the same. That makes it an isosceles. What makes it a right is it's 90 degrees. But if you're looking for a 90-degree angle to be where it usually is, which is like a bottom left-hand corner, it's not there. This sucker got knocked over and turned up kind of upside down, or knocked over onto its let me say, the hypotenuse of the triangle. And so it was a little bit hidden, and I didn't quite see it fast enough. So that is a right isosceles triangle. However, should be able to draw that information, represent that information without being given it. I just thought it would be a cool thing for you to give it a shot, but I gave away the fun. All right, now just want to show you the other screen because there's more fun for you, because if that fun wasn't fun enough, I got more fun. This is nice fun if you want to extend, getting ready for our performance task. You want to extend your understanding of triangles into the world, and triangles and rectangles into the world of just numbers and, oh no, say for example situations like number 10, a chair, a table, and a lamp. It's all, guys, it's all rectangles. In the end, it comes down to the same process, the same thought process of breaking down what you know, labeling what you know, and just following through with the math. So I am not going to do an overview on this one. I want to give you the opportunity to apply what you've been doing with rectangles and triangles and just use it with problems that are not rectangle and triangle problems, except it looks maybe like 11, but ooh, doesn't 11 have a little twist? They're talking about degrees and not lengths of sides. So I leave you to it, babies, in a 20-minute video just about. Give you plenty of work, plenty of problems that you can see to try on, and plenty of answers for you to verify, which leaves you with plenty of questions to come to class with so we can work it out together. You know me as Mrs. C. Love you, and I'll see you on the flip side.